Hello everyone. In previous video we have discussed about that resonance. What is resonance and what are the examples we have discussed? Resonance means simply we can say that whenever one body vibrates because of another body vibrations. Whenever this body vibrations reach to the natural frequency of another body, then another body is also start vibrations to equally to this body. That is called as a resonance. Simply we can say that. In this resonance, by using the resonance tube, we can give the velocity of the speed of a sound in air. This resonance tube contains the reservoir, and what stand which is reservoir is has to move in vertical of movable reservoir, and a scale to measure the water levels. The pipe is fixed to see the water level, and the tube, brass or glass tube fixed to the another part. When the glass tube is filled with the water, then equal levels of water we can get in the brass or glass tube and also in the pipe also. By pouring the water in the reservoir, we can get the total water levels because of these two are connected. These two are connected and levels will be the equal. By moving this water reservoir, we can maintain the water levels in the tube and in this pipe. We can measure by using the scale. First, these are all fixed to a stand. Then, now we are going to see what are the air columns formed in a closed type. This is like a closed pipe of type of pipe. Then, when the vibrated tuning fork taken to the open side of the tube, then by moving this reservoir, we can maintain the water levels by taking this reservoir downwards. Then water level will also comes to downwards. When it comes to downwards at some level, we can hear the sound when the vibrated tuning fork taken to the open side of the tube. We can hear the sound. That level length by measured in the tube, in the pipe by using the scale, that length will be L1. This is the L1. Whenever the air column we can hear the vibrations, then that is the level a node is formed. So that's the level will be, that is a lambda by 4, that is first harmonic. That is first harmonic level. So L1 is equal to lambda by 4. Whenever the L1 is equal to lambda by 4, then what is the speed of a sound in air is L1 is equal to lambda by 4. In that, lambda is equal to 4L1. From that, V is equal to nu lambda formula from the velocity of a wave. Then nu is equal to V by lambda. If we substitute this value, nu is equal to V by 4L1. That is the closed type of fundamental frequency or first harmonic. Nu is equal to V by 4L formula. From that, velocity of a sound in air, by taking the speed of a sound in air, V is equal to root of gamma p by rho. Gamma p by rho. From that formula, the formula substituted in the equation, then nu is equal to 1 by 4L1 root gamma p by rho. Gamma p by rho. From that, here again we taking this water reservoir downwards to maintain the another level to form the another air column, another level of air column mode of vibration, another mode of vibration. Then we can get that another the tuning fork taken to the top of the pipe tube. When the vibrated tuning fork taken the top of the tube, then we can get another sound also. Then that will be the third harmonic or first overtone. The length as taken as L2. L2 is the 3 lambda by 4. From that, L2 is equal to 3 lambda by 4. Then the differences between the L1 2 minus L1 is equal to 3 lambda by 4 minus lambda by 4 equation. Then we can get lambda by 2. From that, lambda is equal to 2 of L2 minus L1 be the equation. From this, we can find out the speed of the sound in air is V is equal to nu lambda. V is equal to nu lambda. If we substitute this lambda is equal to 2 of L2 minus L1, then from that we can find the velocity of a sound in air in a tube by resonance tube. In resonance tube, V is equal to 2 nu into L2 minus L1. Already we know that at open side, the reflection, due to the reflection of wave, the antinode will not exactly form at the open end. There is some farther away from the open end. Already we have discussed in previous video. But so that there is some end correction is there. So that here the end correction will be the at the first column whenever the first harmonic is happened, that is L1 plus E. E means end correction. E is equal to end correction. L1 plus E is equal to lambda by 4. And L2 plus E is equal to 3 lambda by 4. When the third harmonic and our first overtone is happened, then also some of the end correction is there. So that here is also end correction is there. So L2 plus E is equal to 3 lambda by 4. By taking, already we know that lambda by 4 is equal to L1 plus E. If we substitute in this lambda by 4 place, instead of lambda by 4, if we write that L1 plus E, then we can get L2 plus E is equal to 3 of L1 plus E. By the calculation, we can get L2 plus E is equal to, whenever we multiplied inside, then 3 into L1, 3L1 plus 3E. Then by calculating this L2 minus 3L1, whenever 3L1 taken to this side, then L2 minus 3L1, when the E is taken to this side, 3E minus 2E, 2E, then E is equal to L2 minus 3L1 by 2. This will be the end correction formula in the resonance tube. Once again, when we used the resonance tube, first the reservoir is moved to maintain the water levels in the tube. So that's why at the sum of the level, if we vibrate the tuning fork, we can hear the sound. That is the first harmonic. In any point, at all the points, we can't hear the sound. At the sum of the point, whenever that reaches to the equal to the first harmonic or third harmonic or fifth harmonic, then only we can hear the sound. Otherwise, we can't hear any sound whenever the vibrated tuning fork taken to the top of the open end. Only the water levels, whenever we maintain by the harmonic, whenever the length of air column reaches to the first harmonic, which is equal to lambda by 4 or 3 lambda by 4 or 5 lambda by 4, then only the sound we can hear. So L1 is equal to, whenever the length of air column reaches to the lambda by 4, means and the distance of antinode and node, then only the L1 is equal to lambda by 4 will come. After that, by we changing the water levels, we used to do more times by vibrating the tuning fork and put the tuning fork at the top of the tube. By doing this again and again, at some of the level, some of the points, some of the distance, we can get another sound also. Whenever we hear that, the maximum sound and minimum sound, we should hear that by moving that 1 or 1.5 centimeter upwards and downwards, or 0.5 centimeter upwards and downwards, the minimum sound and maximum sound. Is that sound is perfectly coming at the point or not, to verify that? The minimum sound and maximum sound. So here is that by taking the L1, L2 values, we can get the equation, that is V is equal to 2 nu of L2 minus L1. There is, whenever there is some of the end correction is there, then we should follow that. Already we know that from the Rayleigh, the end correction is equal to 0.61 R. R means radius of internal tube, means internal radius of the tube. Whatever the tube we have taken that, the internal radius, this is R. R means internal radius of the tube. This is the about a resonance tube. By using this one, we can find out the end correction E is equal to L2 minus 3L1 by 2 by taking this end correction and the values. Thank you. So here, when the tuning fork taken to the mouth of the tube, then means when the tuning fork taken to mouth of the tube, the tuning fork created the vibrations, moved into the air column. Due to the reflection of the water level, it comes to the, whenever it and node is formed, then it revert reflected towards that, and at the open and antinode is formed. Again and again by doing this, then we can hear the loud sound at a point. Then only we can get the air columns. At certain point only we can get the loud sound. Otherwise, the sound we can't hear, the least sound we can't measure at that point. At the some point of that we can hear the loud sound. So that's why we can get that air columns, length of air columns, that is L1 and L2. Otherwise, we can't get it. So by taking that values, we have the experiment in our Board of Intermediate Education also in Telangana and Andhra Pradesh. We have the experiment also in second year. That is a resonance tube to find the velocity of a sound by using resonant apparatus. Here that by using this we can do it in practicals also. So just we should do this by moving this water reservoir up and downwards. We can maintain the water levels. By at some of the level we fixed the water level, then vibrate the tuning fork taken to the mouth of the tube. Then only at some point only we can hear the loud sound from the tube because of the reflection of the water level by forming the node. If the waves, air columns are reflected, and here node is formed and here the end point antinode is formed, then only we can hear the voice and we can measure the lengths of air columns. From that only we can measure the values and we can take the values by using the formulas. Thank you very much.